Hey everybody, this is Larry. This is June 13th, Friday the 13th, here in New York City in the year 2025. I Today we had a easy problem and I've been trying to do a few more problems than usual, or not that many more, but just that at least when we have a easy problem, well, let's do one that I haven't done yet. And there's a lot that I haven't finished, right? As you can see, at least this many, whatever that meant. So as you can see, maybe I set up. I did I'm going to do an algo problem, and I'm just going to hit this pick one button. Whatever, pick one button, and then randomly pick one. So let's go. Let's see. Hopefully not too difficult because I have to wake up in like 5 hours. We have a hard one. Self-crossing. Let's see. Let's go. Hopefully it's not too hard of a hard, but let's go. 335 self-crossing. You're given an array of integer distance. You start at point 0, 0, xy, you move distance 0 meter to the north, 1, and then to the west, south, east, so forth. In other words, after you move, you change counterclockwise. Return true if your path crosses and false if not. Alright, the first thing that I wanted to look at is the constraints, because then, the constraints are small. Well, one is that it probably wouldn't make sense as a hard problem. In a sense that you could simulate it, you could create a matrix and then just see if it cross, right? But seeing that this is not the case, it's a little bit trickier. I'm trying to think whether and can it move 0? No. I'm trying to think whether. So okay, so you have this thing, right? If it cross, that means that in a way there's like an inside and an outside, right? And for the geometry of the thing, if you have an inside and an outside, then maybe there's some idea of like an area or something like that, and then you maybe do some inclusion, exclusion, or no, that's not the right term. I forget, but like a raycasting type thing of how many things you went through or something like that. So that's certainly an idea. It's a little bit tricky still though, because you can imagine like a spiral that never cross itself, but so you can make that assumption always. This is definitely a tricky one, and definitely at least not something that I know the answer to. Like in terms of like if is I don't know if it's it maybe is a standard-ish thing if you have just the lines, but yeah, I don't know. Or I don't know if there's any standard algo for this, right? Maybe there is. It's just that if there is, I do not know it. So then the idea is okay. Well, we have 10 to the fifth number of lines. They go some distance. The key thing to note that it is always going to be some sort of a spiral, right? But it can still be tricky, right? Because I'm just thinking about edge cases that I have to consider, and kind of, and for these kind of problems, I think it probably makes sense to, it's not. I don't know if it's computational geometry, but it's definitely a problem that we would have to, start drawing things immediately to have ideas. And I'm thinking and without laws of generality, I think we go up first, but it doesn't really matter in the sense that it's like you can imagine that you have someone like this, and then I was trying to think whether you can do something like I see actually. Actually, it's not so bad now that I've drawn it out because it is supposed to be spiral. I was thinking because the key observation is that this is not a general line. I thought maybe I could do something like and I don't know how I could do it, and maybe I can't, but I'm just thinking of something that like I could do something like this, and then I don't know. Well, I was thinking maybe I could do something like this, that so I have two spirals. I mean, obviously this one crosses, but I was thinking like, is there a way? Because now the way that I'm thinking about it is then now you can maybe define a bounding box, right? Because basically you would start at 0, 0, always, you go up, and I think you go left first, right? Yeah. Wait. I guess it doesn't matter if you go left or right first. if they draw, isn't rest to the right side, right? Did they draw this one wrong? Or am I just confused? East side. Oh no, I'm wrong again. West is to the left. Okay. East west is always a little bit confusing for me. My apologies, but it doesn't really matter anyway because there's a symmetry about a problem. But the idea is that okay, once you first draw 4 lines, well, what does this mean, right? This means that everything outside this box is basically illegal, or you can't, or it's just impossible to get there without crossing, right? And that this is always going to go up, right? Because you can't go down, so it's always going to go up. And of course, if you go up, you can only go left afterwards. So that means that now, in a way, when you draw, especially after the four lines, then now you have a bounding box, right? If you don't want to cross. Yeah, now you have a bounding box if you don't want to cross, right? And then it's just maybe like, okay, we go up here, and then now you go up to here, then now you also chop this off as well. So then now you just have a bounding box that gets smaller and smaller, right? Because there's no way to kind of like loop around, especially if you have no 0, right? There may be edge cases with 0 if that was part of the input where you can like essentially choose your direction. But because you cannot, then now you're always chopping off, now you chop off the top, you chop off the left, chop off the right, so forth, right? Okay, so I think the idea is actually fine, and I think we should be able to do this. That said, I don't know that I consider this problem computational geometry per se, but even regular geometry I struggle with. So we'll see how everything goes, right? But with this bounding box idea, we're kind of like in terms of implement like ideas. I think now I'm confident-ish about it, but there's still the implementation part, and the implementation part might not be very easy, right? So anyway, so here maybe I have the bounding box of left, and here I'll set up infinity to be some big number. So we have the left bound is equal to negative infinity, right bound is equal to infinity, up bound is equal to infinity, and then down bound is equal to negative infinity. Something like that, just to, I mean, it doesn't, as long as you're consistent, I don't think it matters. But yeah, but this is kind of the way that I would do it. Set it up, give or take. And then maybe you have a direction that is up. And it's okay. I think definitely it is okay to kind of just write explicit if statements. Like I think with enough practice, you can maybe optimize how you write code or whatever. Like maybe this could be represented as in a way of 4 elements or something. Maybe that's fine. But for now, we'll worry about optimizing code in a little bit. But yeah. And then now what? Yeah. And then now for x in distance, for d in distance, maybe it's a little bit cleaner. Right? So then now, and direction is technically actually, you could maybe write it this way if you will. Index, right? And then direction is just you go to index mod 4 or something. Maybe that's, I don't know, it's a cleaner way to write it. It's just a different way of writing it instead of incrementing every time, right? And then now, okay, what happens when you go up? When you go up, okay, oh yeah, we have to do the current XY, right? So let's actually set that up real quick, right? So what happens when you go up? Well, one is that, and like I said, we'll just do a lot of if statements for now, right? So that means that we have a switch statement or case, well, I mean, switch statement. No, is that how you, I forget how to write switch statements in Python, and I'm trying to get it to stick. Switch. Match. Okay. I forget what it was. That's why. Because case didn't feel right, and then now we have case, so we have 0. So then now that means that we're going up, right? So if and we'll do y as the up direction. So y plus d is greater than, or even equal to, up then we return false, right? Because it crossed. And then if it doesn't cross it, then what does it mean? That means that, as we said, because we're going left afterwards, that means that the right bound is going to be this X thing, right? Meaning that you never hit to the right of wherever line you're drawing up now, right? So here, otherwise, then right is equal to the current X as basically the right bound, right? Again, if you're really slick about it, you could probably write this in a folder for each of the four. Or you could even like, yeah, maybe you could do like an array index manipulation to kind of line them all up. But for now, you know, correctness, right? And then now we're going left, right? So let me write it out. I mean, I guess it shows up anyway. And then left. So if X minus D is less than or equal to left, oops, then we return false. Otherwise, when we go left, what happens? Well, we cut off the top part, right? So that means that up, or maybe, I don't know. That's why I thought up and down felt weird, but yeah, maybe bottom top is a little bit better actually. Yeah, English is hard apparently. Okay, so that means that now the top part is going to be equal to y, right? Because we don't want it to go higher than y in the future. And then now we do if, and this is down now, right? I messed up a little bit in the sense that we have to update this, right? Because now we moved, but you know, yeah. Otherwise, we go down. So then now y minus d is less than or equal to bottom, so we're below bottom. Then we return false. And then bottom is equal to y, right? And then finally to the right side, case 3 plus d right? And then oh wait, I just kind of we said bottoms. I wrote this without thinking. But anyway, we went down. That means that we cannot go to the left of X anymore, right? That's what I meant. Sorry. Oh man, that was pretty bad. Because I was just kind of on autopilot without thinking about it. Okay, now that we go right, that means that we cut off the bottom piece. And then the bottom is equal to y, right? And that's it, I think. And then if all these keeps on passing, then we just return true. And we should be Gucci, hopefully. So we give it a spin. Oh, no. Why not? Did I mess up something? Maybe. I mean, at least it's easy to, oh. Direction, no, I mean, you know, yeah, it's easy to debug maybe. I don't know, we'll see. And then left, right, top, bottom. Maybe, yeah, we might have to fix it, but it's fine. Okay, so 0, 2, yep, that sounds right. And the right, yeah, we don't go there. But, oh wait, did I? Oh, no, okay, so I think it just seems like, no, I'm right. Well, I want to say I'm right. Oh, what is going on? I don't like all this like random UI weirdness thing. I mean, okay, so I returned false because I just misread the problem in the sense that I returned false because it does intersect. So I think we just have to flip all these things. I think we're still wrong, but I think this at least fixed the first one because I was like, oh, that doesn't make sense. With false, I said it doesn't self-intersect after all the loops. So yeah, so we can set that. And now, yeah, case 1 is right, case 3 is right, case 2 is right, or incorrect. Why? Oh, so maybe I am wrong on my bounding box. Huh, okay. So that was okay, well, back to the drawing board. I'm just really wrong, not even close. I was, for some reason, I was thinking about, I mean, that's what I was trying to think when I was drawing the double helix, but then I just got confused. It's very easy to get confused. But all right, I mean, it is an example too, so that was pretty bad. But it's okay. It's part of the learning, right? So here, now we say, I mean, there are really only 2 ways. I suppose, because no. Okay, yeah, that was the thing that I had in my mind, but then I forgot with the double helix is that you could do something like, but now it makes it hard, honestly. Because before, so you have someone like this, and then this, and then now once you're in the helix, then you know, so you could do something like that. Okay, well, time to re-evaluate how to do this problem. So I was way wrong. But that's why you want to, you know, not prematurely optimize the code because, well, you may be wrong, as you can see. How do I think about this in terms of implementation, right? And then of course, so we considered the top half of the case in the sense that we, you know, the problem that we have was something like this, right? And then the other one is, of course, now you have to think about it. Oh no, this is I meant it the other way. Sorry, I'm confusing myself even on the thing. But we did consider this case where so we only consider one case, which is that about this, and it just keeps shrinking, right? But then now we have to consider the other case of it starting from the inside and then getting bigger. And then, as you can see, the combination of both. I mean, yeah, that is tricky. It is tricky to have a simple solution. I mean, I think it's fine. Maybe I shouldn't have been too fancy. Like, I think maybe it is just as basic as it sounds, which is we just draw the lines and then see if they intersect using a data structure, right? And maybe that should have been the first thought, but I thought maybe I saw a pattern that I was wrong about. What I mean by that is just that, okay, you draw a first line, now there's a line exists, draw a line and see if it intersects any, right? And then now here you have all the lines. Maybe you have a data structure, so then now you could query whether this line intersects with any other line, right? And that's really how would I do that? Trying to think of what is a reasonable data structure. I mean, we could keep a track of the x, y's, right? Like, you know, so we could do a quick query, and then within that, maybe we could do a binary search. So maybe 2 binary search is fine, right? We just have to keep track of all the lines, and maybe that makes it more rhythmic instead of problem solving per se. But yeah, I don't know why I did it the other way. Now that I think about it. It is one of those things where as soon as you realize you're wrong, everything is a little bit clearer. That's bye-bye. Okay, so okay, I think then I'm just trying to think through the actual like edge cases of the implementation detail. Specifically, literally on the edge of like for example, if you did a literal box, then you intersect with all those points, right? But yeah, okay. So now you have x, y is equal to 0, right? So then now for d in distance, you have direction. Yeah, fine. Direction, or I guess technically it'll be enumerate, right? And then now you have directions. So then now we go up. So that is this. If we go positive y, left is -1, 0, and then yeah, then you just kind of fill it out, right? And then maybe we have now nx and y is equal to x plus dx, y plus dy. And then now we're drawing a line from xy to nx and y. And without loss of generality, I think we can just sort, right? So that it always goes from one direction to the other. right? And yeah, if x is equal to nx, then this is a y line, right? Sy ey is equal to min of of y and y, max of y and y, right? Something like that. And we're going on x, so then now we're drawing a line from xsy to xgy, and that's fine. We have the data structure. So what are we? How are we searching, right? So we want to. I guess it's not quite that simple. How do I do a two-dimensional thing? Because I was thinking like, okay, well, we can binary search for the y components, but then now that means that we have to put all the x components together, and then if we do a loop on that, that's going to be too slow. So you need to pre-process the x as well somehow within those y's. And I don't know that I know an easy way to do it. Do I know an easy way to do it? Let me think about it. I mean, I'm not worried about. Well, I'm thinking about the data structure that we need to get from this point, right? I mean, and I know there's stuff like KD trees and quad trees and stuff like that to kind of, you know, do these kind of things. But I'm wondering if there is a easier way to do it. And I'm trying to think like, maybe you could think about it as a 2D prefix sum kind of thing. But I mean, maybe that's true. I don't know. Because the way that I'm thinking about what I mean by 2D prefix sum is that if you kind of think of it as, if you think of each line like, if you think of each line as dividing two areas, so then now that means that, let's just say this is a line, that means that you have two areas which goes from here, the red area and the blue area, right? And that means that it intersects if you're drawing a line from, well, one area to another area, right? That means that it crosses. If it doesn't cross, then it doesn't cross, right? Now I was going to say something like, I was going to say something like, you know, you could think about this as a prefix sum, right? In that, you know, you draw a -1 here, and then on the left side, maybe +1 on the right side or something. And then as a result, then now, you know, you're in two different areas. But maybe that is similar to writing a tree situation, like a KD tree or something, or at least a quad tree or something. I don't know. So maybe that's kind of like, that's not an easy thing to do. I mean, if we have to, we could come up and write it, but I don't think it's an easy thing to do. So we have to figure out another way to, you know, maybe mark these, and also in a way that is, you know, like scalable in a way, right? Because that's one line, but like, let's say you have another line like here in the past, maybe for whatever reason, then now you have to kind of figure out, okay, well, like you have this right side, this left side, and then how do you figure out their difference? But yeah, I think oh, excuse me, man. This is not a good day to be doing a hard problem with how do I implement this? So it is the idea what I'm thinking, but honestly, I'm stuck at this point in terms of without doing something crazy. So so do give me a second to kind of think and maybe I could grab a water or something soon. But yeah, that's basically what I'm thinking. Or if I'm missing some obvious way of kind of doing this, That's why I was looking for a simpler way out, because otherwise it is just too hard. I don't know. I mean, maybe the other way is just to edge case it, right? Like we already did the thing. Okay, we don't. I already erased the diagram, but we already said that there are only 3 distinct cases, right? Oh, and I wish I didn't delete the code for the other one. Or like I don't mind deleting it, but I wish I kind of kept it somewhere because we might have to write it again. But because 2 of them is easy to do, and maybe we can combine them. But there's just it is definitely like a very awkward problem to do it in a more general way. I'm trying to think. Right now, I'm just still trying to think through the the diagram that I drew with the -1s and the +1s, and then you could kind of in that way label different sections. I don't even know if that would work, honestly, but basically, if you're in a I want to say if you're in a positive section, you're okay, but maybe that's not quite right. Because in that sense, it's just like drawing a color, right? And you can intersect the colors however you like, but like you're coloring in all of the regions. I don't know if that's easier than actually creating all the lines, but I mean, what I am thinking is that it is like a 2D prefix tree type thing, but that's still like not a easy thing to do. Hmm. Is there any other way of doing it? And you have something like this, which is obviously like also like just messy to do on the line with degenerate line stuff. Um, uh, I don't know. Eh, what is it? So you draw a line. Like I'm still trying to figure out like if I was to color a region, I guess I know the answer. It's just I don't like to do it. Um, or is it easier to just query the lines? Can I put the lines in a good post for querying? Yeah. I think one thing that I would say, an observation, is that order. I mean, it's not sufficient because it's very awkward. But all the distances are, if you separate them just by odd even, meaning up down and left right direction, then it has to be monotonically increasing and then decreasing, right? Or the other way around. No, it has to be decreasing. Well, it could be increasing if you're starting from the inner one. So then it looks like this curve. But is that sufficient? What I mean is that if I think about this, if you just look at up down, then here, though it doesn't solve this one because it goes, it's exactly like it goes 1 1 1, right, on up down, and then it goes 1 2, which happens to cross. But without without the case where it crosses itself at a point, well, it crossed anyway. But if it didn't cross, then it has to be if it didn't cross, then it has to get bigger, right? And then maybe get smaller as it shrink, like a normal spiral inwards. I mean, that is an idea, that is an observation. I'm trying to think how much usage I can get out of that definition. Meaning, like, I mean, it is a property for sure, but is it a sufficient property? Meaning that is this property, this observation, is enough to solve the problem? Or it may have a lot of edge cases like this one, right? I think this is a very degenerate case. I mean, yeah, so there's like this line property thing, but I feel like there's still a lot of if statements or like not even if statements, like if statements are not, evil or anything, but just cases that I don't know that I can account for order, because like earlier with the directional thing, like I could see that I only have 4 cases, right, up down left right, but in a lot of these edge cases I feel like there's a lot of combinatorial combinations, right? Like, okay, well, let's say you have like an if statement, but then now you rotate them, and then now the 4 rotations. So then now your 2 if statements become 8 if statements, and then maybe now there's another thing with, I don't know, symmetry or something, and then now your 8 becomes 16, and then like, is that scalable? Maybe not, right? So these are the things that I'm thinking about, right? Draw a line there. What does that mean? Well, okay, maybe I can just draw a line because I think of the property again. Then now, you can eliminate a lot of things. Because, okay, let me think about this by drawing it out a little bit. Because the way that I was thinking is that, right, so that I was thinking if you draw a line from here to here, and you have all these lines you have to kind of think about, right? And then from here, like maybe my initial query was to think that, okay, well, like we take account these ones, and we filter out, say, the stuff that is to the left and to the right, we filter those out. So now we have these, right? And then here, like naively, you would maybe have to do a for loop, which is expensive. Well, maybe what if there's another way around? What if instead of that, we take all of them, right? We filtered out these ones instead, which does not intersect in that direction, but only taking the stuff that is that basically you do a query of this line, if it extends all the way to infinity, and see what intersects, and then for each one we just look at the x values. Would that be fast enough? Or can that be written in a fast enough way? You still have to do linear in the worst case though, right? Can I store that in a fast way? Because then now what we're doing is that we are storing, for each one we extend this to infinity maybe, but then now we have to store just and we can really aggregate over them in a really meaningful way. But you don't want the max or the min. You want to know. Yeah. Maybe that doesn't change anything. I'll just try to play around with this idea. I mean, I think the idea is still. Maybe it is one of those problems we have to go into literature. Like I still have this idea of just, you have this line which divide this into two sections, right? Sorry, man. Maybe I should. Maybe I should have filtered out hard ones, at least for today, because only because I have to wake up early tomorrow. And some days I do, but I forgot. Today I forgot about it. Okay. So this is the spiral in that I had before, but that means that here, well, there are two. So this is one example, but then you can also have something like this, as we said. I'm drawing it wrong anyway, but I just move this up. This isn't the way. I guess it always has to be vertical. I was trying to draw the thing that I was doing earlier, but horizontal, but maybe that's not easy to do vertically. Because here, then now you have something like this. I'm trying to see. I mean, I think I'm seeing a pattern actually, and just drawing it out. And maybe that's why you have to draw it out more. The key idea when you kind of draw it out is that there are only a couple of lines that it can intercept, right? Meaning that if you're going here, going this way, all the lines that you're looking at, it's going to be up. Right? So first thing, that's to note, actually. Because it can never go down. Well, that's not true. Maybe. Is that true, actually? Let me see. That's why I was trying to draw a vertical one, actually, but or horizontal one, sorry. And maybe, I mean, you probably can. It's just that yeah, maybe something like, oops, like here. But then it's just that it extends out this way, right? So then now this is how you draw a horizontal one, though it's more awkward, for sure. And pretending that I didn't hit my table when I drew this, but so now when you go to the right, you only check. Do you ever check a downswing? No, right? Because of the direction error? Is that true? Am I lying? Going down, you never check. Let's just stay with one direction because without loss of ground is the same. That means that going from left to right, do you ever even come? No, because you always are tied to the back. So as a result, like you never see one where it comes to this, right? Okay, so that then by itself, like this would never happen. Because every down can, I mean, there's a down here, for example, but that's in the future, right? And similarly, maybe, let's see, here, we would, if we go down, no, that's not, okay, so I'm wrong about that, right? Because, let's see, let me redraw it. Because I was saying that, you know, you can definitely do this where, you know, when I go down, you know, I was thinking like maybe there's some angles or something, but it seems like for this, let me change the colors real quick. For this line, like it would never check a left, but as you can see, we need it to check this left here, right? So that's not true. I was thinking that maybe like on a down hit, you only check a previous going to the right. But this is clearly not a case for that, right? Or maybe, is it? Yeah, I mean, I think with this problem, definitely just need more drawing in general to play that out. I think I've been trying to do too much in my head, which is generally not a good thing because my head is small. Okay, so then now, no, yeah, no, the other case that I was thinking of is checking, crossing the down, right? So that means that maybe like this, and then now, then, yeah. So I was just trying to figure out if there's a way to simplify this, like maybe the directionality matter. I'll try to figure it out whether, like, you know, if for this particular line, does it only like if you go down, did you only intersect with left facing line or right facing lines, right? And maybe we could differentiate that still, but as you can see for now, this line going down will intersect with both left, a line going to the left and a line going to the right, right? Oops. So there's no So you can't filter it by that or have some ideas about it. And furthermore, as you can see for this one, this is not even anything recent, right? Though, I'm trying to think. If this intersects with a line going to the right, like we have here, can you do it with a line that intersects to the right that isn't, was it 1, 2, 3, 3 steps previously? Right, because going to the left, you can, yeah, this line is a long time ago. Actually, is it? It's 1, 2, 3, 4, 5, right? Because I mean, I'm the reason why I'm counting this, and in here you have 1, 2, 3. The reason why I'm counting these is that this is, you know, this is what happens when you analyze a lot of problem, or not a lot, but even just this problem in a particular way, is that in a way, if we go back to our first attempt at this problem, we have this idea of bounding box, right? And what does a bounding box mean? Bounding box means, at least the way that we did it, because I was thinking that, okay, well, it goes up, we go to so then now you have this idea of bounding box. But what does a bounding box mean, right? In this scenario, another way to think about it is that, okay, well, this line is just 1, 2, 3. This line is just intersecting, because the way that we chopped it off, it just means that another way to phrase it is that we're looking at the line 3 line segments ago, right? Okay, that's fine. And by definition, we can't intersect with the previous line. Just, it doesn't make sense. I mean, or it does intersect, but you know what I mean. Like it intersects, but it's not self-crossing, right? But then now, if we think about it the other way, I guess this is the other scenario of, okay, 5 lines ago, right? Because, well, what happens if this doesn't happen, right? What happens if, and let me just draw it here. What happens if we don't intersect 5 ago? Well, we go this way, and this way, and then now, let's say we don't intersect. What does that mean? Well, now we have to be in the bounding box thing again, right? So then now you only have one chance-ish, you could say, to intersect from something 5 thingies ago, right? Because then now, let's see. I'm just looking at like a random line inside the top thing. Like for example, this one, right? What can it intersect with? Well, it goes right, so it would intersect with 1, 2, and again, just this line, right? It can only intersect with this line. By definition, it won't intersect with this line, because if it intersects with this line, then it intersects with the previous line segment before, right? So it would only, so that means that even, because I was actually thinking about this earlier, about the idea of the line segment that goes bigger, and then the spiral that grows bigger, and the spirals that grows bit larger. Originally, I was also thinking about, you know, we had the bounding box for the one that goes smaller, but I was like, okay, well, maybe I could do the one where it goes bigger, right? But if we do the one that where it goes bigger, how do you do the one that does both, right? Which is, I guess, this case. Because you can do a bounding box for the one that gets bigger is what I was thinking of, right? Because here, instead of the bounding box chopping off all everything's impossible, inside this one, you just means that everything inside is impossible, right? So the same idea, but like the opposite, almost the opposite of the first idea that we had, right? And so, and I don't know, I think I'm just trying to convince myself more than a proof. I think during a contest or something like that, maybe I would YOLO, honestly. But I think what I'm trying to say is that, okay, well, if you have a spiraling bigger situation, you only have to look at the line 3 lines ago. And here, you only have to look at the lines 5 lines ago, right? You don't look at the one line ago because it's just useless. 2 is parallel, so, you know, like you don't look at it. So that means you only check for line 3 lines ago and maybe 5 lines ago. And of course, if you only check intersection of 2 lines, well, that is, I mean, that's just easy to write, right? Line intersection and their axis, axis parallel, or axis. Man, it's one of those things where I said the same word a few times and I'm just confused. Axis orthogonal, maybe? I don't know. But, well, no, axis parallel. Is the right word. What am I thinking about? I mean, but they only intersect at right angles, right? So, okay. Yeah, I mean, I think that's, yeah, I mean, I think that's it, right? Okay, so then now we have this. All right, we have the right n. Oh, I didn't even write the dx. Oops. Dx dy is equal to directions of direction. I think that's what I meant. And then now, that is a cute trick though, or observation of, because I was thinking about it in bounding boxes, but in a way, bounding boxes is just checking line intersection against the lines 3 lines ago, right? And I didn't think about but now that we make that translation, then now we could make the analogy of the 5th line, right? That means that yeah, here, if intersect, okay. I was gonna, I mean, maybe we can just write lines. You could probably do some math on the index and stuff like that, but we could just put in lines, right? Yeah, lines dot append. Actually, let's just put here xsy, y xuy, right? Else y is equal to ny. Start x nx is equal to min x and x. Line start append, right, same thing. Something like that. And then now we just check if length of lines is greater or equal to 4, because there's 3 lines ago. So then now if intersect line sub 0, line sub, oh, not line sub 0. I mean, it's direction is zero. Let's go to index. And also, of course, I had it on the earlier code, but this is index mod 4, of course. And then, yeah, this is going to be intersect of line index and index -3. Right, then if it intersects, then we return across, and then we do the same thing. And I guess it should have been, oops, 5 lines ago. So it's 6 lines, right? And maybe the better way is just like index -5 is greater than or equal to 0, just to be and for consistency. Something like that, right? And you could have put this in a for loop. This is an easy for loop to imagine. But it's easy. Well, I feel like I could do it. And otherwise return false. And now we just have to write the line intersection formula, right? Which, I don't know, it's annoying for sure, even with this. So we'll see. start line 1, line 2, right? So then how do I do a line intersection thing? Yeah, I mean, it's just okay. I'm just thinking about how to write it as like not as crazy as possible, but it's still very tricky. So basically now, yeah, I mean, just do it, Larry. Okay, fine. I mean, we could even do if statements if we need to, which is that if line 1 of 0 is equal to line 1 of 2. Keep in mind that we always have like a cross possibility. Like it may not intersect, but it's always they're always orthogonal the way that we set it up. So that means that if line 1 is this x is the same, so that means that the y is different. So it's a vertical line, right? And if it's a vertical line, then we just have to check a horizontal thing. So we check whether line 1 of 0 is in between line 2, the x-axis of line 2. This is very, yeah. So if this is not true, then we return false, because then that means that okay, so you have a vertical line and then you have a horizontal line, and if it has to and you reduce the horizontal line by the x component, and then it has to intersect in that way, right? If not, then it's false. And then if it is, then now we check line 2 is horizontal, the y component is the same, right? And then now if line 2 of y, so this is the y component of line 2. I really should use a enum on this actually. Yeah, well, not a enum. Sorry, I mean a named tuples is what I was going to say. Maybe we still can. It's too late. All right, I'm lazy. Well, we'll see if it's correct, because I'm just still worried about correctness, honestly. Right, so if the y component is between the y component of the first one, then now we return true, otherwise we return false. All right. So line 1 is horizontal. If not line... Okay, so line 1 is horizontal. Then actually, maybe we're lazy, so we can just... and what I mean by that is then we can just return intersect of... Because the horizontal case is just them going backwards, right? Alright, maybe this is okay. Let's see. Distances is not... Where is... Did I put distances? Oh, how did that happen? Okay, so still wrong. Why? Why did I put true? I'm in the sect. Okay, so it goes do. Is this not right? Because base, because this is returning true for, and it can only be here, right? Line, the last line is horizontal. So it tries to do this, right, which is swaps, which should be fine, because then now this should be true. Yeah, and it's from 0 to 0, right? Line 1, that means that, okay, this is true, so then now it goes to here. Did I do this part wrong? Oh, I'm definitely do this part wrong, because you know, we're comparing the x components of something with the y component of something, so something is really weird, right? We're comparing the wrong things. Okay, I mean that's an easy fix. Should be just 1 and 3, but maybe not. Okay, let me actually think. Okay, so line 2 is horizontal. That means that the y components are the same. So this is the y component of line 2. Line 1 component of... Yeah, I mean, unless I did the min-max wrong. Min-max... Because this is returning true for some reason. Right? Maybe? Let's see. Yeah, see, this is printing out. Well, I mean, this is just wrong. Oh, I'm dumb. I didn't update. Okay, so it's a easy fix, right? Because xy is going nx and y. I forgot to update. Because I was seeing 0, 0, right? So that's why. I mean, it's still wrong, but at least... No, it's still wrong because I don't know why we're drawing it. Like, we should not have 2 points at 0, 0, right? Only for case 2. Something is a little bit awkward. Trying to double. Okay, well, let's just print out all the lines. Maybe I'm just being dumb somewhere. Okay, so 0, 1, negative 1, 1, negative 1, 0. That's not right. It should be plus. Did I mess this up? Oh, I didn't use D. Okay, I'm just dumb then. I mean, I spent so much time focusing on the hard parts that I kind of was just very sloppy at this part. Because you will recall I got that wrong a little bit. Like, or even when I didn't debug, I was getting it. It was just not. It was just sloppy. Let's give it a quick submit. Oh no, wrong answer. Okay, what is? I mean, that's fine. That's what I mean. Like, this one has a lot of weird edge cases potentially, so I'm just worried about it. But that's, you know. So okay, so it goes up 1, left 1, down 2. Oh, and it starts at the it starts at n at 0, 0. So did I miss? I see. So I mean, this is one case where neither the 3 and the 5 holds true, but it goes to 0, 0. I'm trying to think. Okay, so I did miss a case. I don't think that it. Yeah, I was trying to hoping for something elegant like this, but I did miss a case where because I thought that you have to be like a cross thing, right? But here you can see that if I did something like this, and then it goes just straight up, then here, well, okay, here it intersects with this one, so that's a bad example. But let's say I have something really long and then something like this, and then here I mean I'm writing it a little bit to the left but pretending they intersect, right? So that means that here and here they intersect on a, because we only compare horizontal line and vertical lines, and we have this degenerate case. Is this the only case where it can be? That's what I'm trying to think right now, is this the only case where it is quote unquote impossible, right? Or where it intersects with a former thing. And what I mean by that is that you can imagine like we have this, well then going up, what does that mean? That means that we only intersect with the fourth one, maybe? Like, it's not possible to intersect with before fourth, right? Well, okay, so maybe I mean, we can just iterate through the cases, I think, because here, as you can see, and I didn't consider it for some reason. I mean, it happens. We have this is 1, 2, 3, 4, right? But there's also a case that is similar, and also similar to what we drew before, of someone like this, and then maybe we go like, oh no, but here, oops, if we try to do something like that, then it intersects with this line, right? So that's okay. So that's already taken care of. So we don't have to do, even though in this case 1, 2, 3, 4, 5. So this would be the 6th line, but you don't need to because it would hit the 5th line before. So then my other thing is, can it hit like I'm trying to think of like, can it hit the 6th line in any other way? I guess by definition 5 would block it. Can you hit the 2nd line? No, because just like we proved by contradiction in a like 1, 1, 2, because this length is 1, it could never, these 2 lines can never match. So that means that we just have to check the 4th line for this case, right? And it's very annoying, but that's fine. Like, we could do it. I'm just trying to, right now it's not whether like we can fix it for this case, is me trying to think, is fixing it for this case enough, right? And also this wrong answer is what I was worried about with other ways of implementing it, right? Is that, okay, you try to fix it for, it's almost like those cartoon movies of like you plug your finger in one hole and then the water comes out in another way. You plug it there and then water comes out, and then, and you're like, poking at everything. And in this case, it seems like maybe that's it, right? You can't hit the 2. You can hit the 4, obviously. You can hit the 6 without hitting the 5. And beyond that, I don't think there's any more, right? Because here, or even here, right? Like if we try to go this way, go here, it would hit the 5 before hitting the 4. So really, there's, wait a second. But here, oh wait, no. Oh no, this is 6, not, well, this is 5 rather. No, but here then now it intersects to 5. So are we? So okay. So that means that we actually do take it. That's why that's why I'm trying to think through before I implement, right? Is because here we actually do cross the 5 given here, right? So then the only reason why we fail is because we don't have a 5th node. Is that true? Because here then now we go this way, we can go up more, right? So we do have to compare with 1, 2, 3, 4, because there's no 5th edge to kind of write this out, right? Yeah, I mean, I guess that's the thing. So we can check, and I'm trying to think whether we could even, like, is this a very particular special case that we can if statement it away? Because if you only go past the middle or the starting point, that means that you will never even like, let me see. I guess no, but then this is a line intersection, so we're good there. Because I'm trying to think whether it is possible to. I mean, we can't draw this, but something like this, right? Like here, like can we draw it in a way such that this is true? But I don't think so, because you always have to start. Oh, actually, but then that always has a line, right? Because now there's this line, so then these intersects. So you can never have a horizontal one. That means that this can only come up vertically, and it also means that it only intersects in a degenerate way line 4, right? Because if it only intersects at the starting point, well, one way is that you can do some if statement, but that means that line 1, if you count it, now you go counting forward, so it's index 0. Let me use another color. Index 0, 1, 2, 3, 4. Right? So that's fine. We can write something like if, so lines of 4 goes through 0, 0. Okay, so, let me take it off. Sorry, I'm writing code and I'm not showing it. I wrote this line, that's it. Yeah. If line, if the fourth line goes through the origin, right? Like we don't even have to compare the line. We just know that it has to go through the origin of 0, 0. So then now, if that means, and it is always a vertical line, so that means that the y component, if the fourth line's y component goes through 0, and the x component, and by definition the x component will be the same because it is a vertical line, and if the first x component is equal to 0, so maybe that's actually should go first because it's an easier check. Then we return true. Oh yeah, of course I'm gonna check that. Oops. Right. 1, 2, 3, 4. Okay, that's the fifth line. I lied about the fourth line. That's pretty bad actually. Off by one, because I was trying to figure out, wait, how am I getting 4 lines? But for some reason I started at 0 index, and as a result, yeah, I was just counting the fourth as in 0th index 4th, so that's why it's 5 lines. Okay, let's YOLO submit again. Yes, I mean apparently this is very slow for some reason, but I'm pretty happy with it. It is a tricky problem. I mean, complexity is easy to analyze, but I'm just trying to think like how I could have gone faster. This video is 1 hour and 10 minutes long, which is really long. I mean, I'm explaining, etc., and try to prove it a little bit tighter than I would normally. So you can say maybe I could be a little bit faster, but and maybe during a contest time I might YOLO on this part instead of trying to think through all the exhaustive way of thinking through it. But yeah, and you can kind of see a lot of it is just drawing it out. I think that's why I am very big on visualization. Once you kind of draw it out, and I had a different visualization initially, right, with the bounding box, but and the key observation that ties all this together is that this is not a generic problem. The key part is that it only, like, you can only, like, it rotates, right, is what I mean, in a weird way, and that leads to all these properly, right? And when it comes to problem solving, I mean, of course, I don't know that this is a good example of that, but I would also say that you know, this is a unique, an example of perhaps a property that you might not have come across just from experience. I mean, I might have, honestly, just because, you know, it's been a long competitive career, say, but I don't remember it enough clearly, right? That part is clear, whether I came across or not in the past. I was not able to reuse this properly. I mean, I guess somewhat I did with this bounding box thing, but this one is, you know, even more specific than that. Like, I don't think, and to be clear, like, you know, it's not worth memorizing this, right? Like, this is like I don't want to say this is a one-of-one problem, like a unique problem, but it's just like, how often am I going to need to know, you know, this particular property? I don't know, maybe even never, right? But it is but having the tools to kind of play around all these properties and coming up with all these properties and or different variations of the same property, even maybe the bounding box would have been more interesting if we can only spiral inwards, for example, right? You know, that's problem solving, right? And that is the difference between solving like a Q4 in a contest and I don't know. I mean, I guess that's it, right? And not, but yeah, the complexity is just linear, right? I mean, there's a lot of funky things going on, but at the end of the day, we just look at each line and compare it with 2 other lines, and then maybe another if statement, and that's it. So linear time, linear space, and you probably don't even need linear space. I did linear space because I put all the lines together. You can actually do better, right? I mean, this you can just do specifically for obvious reasons, but here you can just keep track of the last 3 or 5 lines, or you have to keep track of the last 5 lines, and that is a constant space, right? And that's it. That's all I have for this one. My apologies for doing it kind of a hard one for a bonus farm. I usually try to filter them out, but today I just forgot. I mean, it is what it is. You take what life gives you, and thankfully we eventually grind through it. Yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye bye.